As Ricky mentioned, this topic of digital twins came up yesterday during a panel that Joyce led. Some people had some really good questions, so I hope those people are in the audience today. And I'm excited to dig into the topic a little bit deeper. We'll leave some time for Q&A at the end, so get your questions ready. But please welcome to the stage, we've got Matt, Marc, Brian, and Anil. Come on out. And I'll let you all do a brief introduction of yourselves. Marc, why don't we start down there with you?
Very good. Thank you for the opportunity here. An esteemed panel, indeed. I'm Marc Goldman. I'm the Director of AEC Industry Solutions at ESRI. ESRI is a global GIS software provider going back more than 50 years, pretty well defined the industry and continues to lead with technology and innovation. I lead the effort to get the word out that GIS software, Geographic Information System software, is very well applicable and powerful in architecture, engineering, construction, and large capital projects around the globe. I work with architects and engineers and contractors, owners and operators at all levels, helping them understand how their building information modeling technologies, their CAD solutions, and GIS can work together to deliver digital twins as well as many other capabilities.
Thanks. Anil?
Thank you very much. My name is Anil Sawney. I'm the global lead for the construction and infrastructure sector for RICS. RICS is the Royal Institution of Chartered Surveyors. We are a not-for-profit professional body with about 135,000 members globally. We have a royal charter in the public interest. Our members work from what we call land to disposition. So out of these 135,000 members, we have members working in the area of land, asset management, construction, infrastructure. My focus is construction and infrastructure. We develop international standards, work in bringing new knowledge and information to our members so that they can serve communities better through their professional skills. And digital twins happens to be one of those areas where our members are picking up speed and trying to provide more services at different scales, maybe at a building scale, at a city scale. And we are here in the real. Marc and I, we always sort of joke around that it's our digital twin that's meeting via Teams. But in this instance, we are here, happy to share information and knowledge relating to smart cities.
Thank you. Brian?
Brian Dillard, Chief Innovation Officer for the City of San Antonio, and I think this is the last time you have to hear from somebody from San Antonio other than Joyce. So under our office, we've got 4 teams: digital inclusion team, R&D, research and development team, performance excellence team, so process improvement within the city, and then our smart cities team. And that smart cities team in the past is kind of focused in on their own things, and we are now remodeling that to be kind of a smart cities as a service, not only for the 40 plus departments within the city of San Antonio, but our partners throughout the region. So this would fall into my category of operations simply because I got to cram it down everybody else's throat.
Matt?
Good afternoon, everybody. My name's Matt Sokol. I've been serving as the Interim Chief Data Officer for the District of Columbia. I actually work out of the Office of the Chief Technology Officer. My job really is to deal with a lot of things, all related to data. We have an open data program that's very successful. We provide data services and data strategy to other district agencies. We focus a lot on data integration, big data, various types of storage, API development, so middleware, anything that kind of moves around, cleans, exchanges, transforms data. That's our group's role. The district's been involved in digital cities efforts, and where I really come in is talk about how do we deal with bringing that data in, moving it around, how do we store it, how do we properly visualize it, and then how do we bring some other things around it like governance and operations for things like GovOps around the city.
Great, thank you. Before we get into the conversation, Marc, you've got a couple slides. So.
Yeah, I just wanted to frame the conversation a little bit with some examples that I've used over the past maybe couple of years now about digital twins. Yeah, let me just jump in here. So, let's move this forward. There we go. So, the topic of digital twins and location data and digitizing our built world is one that is near and dear to me. I've studied architecture and engineering many years ago, but the technology side of things was more important for me to try to solve problems than designing the next great structure. My few years at ESRI now, it's become very clear that projects that get built somewhere. Projects that get planned and designed somewhere is a critical element, but yet the context is often not front of mind. The tools that architects and engineers, contractors and owners and operators tend to use doesn't necessarily take context into mind, but however, spatial information, location data, the core of a digital twin, this type of information that is location-based, is critical. And this type of information is a connector in many cases. The softwares that are used to build and organize and keep our physical world running digitally, spatial information can be a connector for it. And that is what's been enabling digital twins over these last few years. Spatial data tends to connect the software, it connects the workflows, and then it connects the people. And by connecting people, you're able to put into place the digital transformations that we're all talking about and striving towards and promising to be the thing that improves our operations and such. And then once you've done that, once you've considered location-based data and have the capability to do spatial analysis and bring together CAD and BIM and location-based data and schedules and asset information systems, you're essentially talking about digital twins, this connection between the physical world and the digital replication of it that isn't just a view of that building or that structure or that roadway or that network, but it's actually a real-time and maybe even historical view of that data. So from ESRI's point of view, we look at digital twins, we look at this world of digitizing our built world, at least from the AEC point of view, in sort of four lenses. One is around planning and urban design, the fact that digital twins allow for site selection, for land suitability analysis, for transportation modeling, and so many other cases. This is just one example. This is from Tel Aviv, Israel. I was recently there. Construction technology is absolutely booming in Israel right now. And this is just a project showing a portion of Tel Aviv, a 3D model of a building in context, in location, with sunlight information studies available to understand what the shadows are going to be on the buildings surrounding it, additional information layers able to be overlaid to understand how this new structure is going to go up. And then once the building was actually built, a drone flight around the building allowed the context of this new structure in context to the existing environment in a real world visualized type of environment. We also look at digital twins more in the natural world as well, not just the built structures around us, but the natural world itself, allowing environmental managers, environmental consultants to have repeatable methods to analyze, reduce usage, to be more optimal with the materials and the resources involved in environmental projects. This is a port in Taiwan where the 3D environment was generated via drone capture, and then in the environment itself we also had 5-year, 10-year, 50-year flood projections modeled so that when the new buildings that were planned to be on this pier were developed, they actually could be visualized with those different flood levels incorporated. And in this case, the BIM model, generated probably in an Autodesk application, incorporated in a GIS view, allows the environment and the built world to be visualized together. Design and engineering is an area that initially comes to mind when people are thinking of digital twins. It's the architects and engineers who are building the 3D models, who are building the plans and the visualizations. It's part of their day-to-day work ongoing. What digital twins allow, though, is what-if scenarios to be more easily explored. So it's not just a single 3D model that solves the building program or the infrastructure plan, but digital twins allow for more what-if scenario planning. So in this case, this is the city of Paris, where they took data including demographic information, where population centers were, where existing train stations were, and the usage of those train stations, and then incorporated into that same environment for a large group of stakeholders to explore and understand the 3D model of a new train station. so that the constituents, the stakeholders, the actual individuals who would be riding that train at some point could interact with the model itself, understand both above ground and below ground what the environment would look like, all in an environment that's presented via the web. And then once the models were developed and incorporated, they also added actual usage of trains and buses around the city, again, in this singular environment. This, you could say, is a digital twin of Paris focused on a particular train station expansion. And then finally, construction management is an area that digital twinning has really been catching on. The idea of being able to reduce cost, reduce time frames, create safer environments through construction. This is a US-based project, Norwalk, Connecticut, I believe. An old lift bridge is being replaced with a newer bridge. The old bridge has machinery up top that needs to be managed and maintained, temperature and such. Right next to this bridge is pile driving for the new construction. So on the bridge itself, you can see right there on the screen, one little blue column, that represents an IoT sensor, which is picking up on seismic activity, temperature, any movement that's occurring because of the pile driving right next to it, so that the construction team can know when to stop their pile driving, when they might be actually damaging existing structures by digitizing the real world in a view like this. So construction management is another area that digital twinning, from an AEC point of view, is taking hold.
Thank you for sharing that. It's really cool to see the visuals and just some examples of the ways that digital twins can be used in the real world. So how can cities use these digital twins to better manage some of their assets?
I need to talk to one of the city managers.
Yeah, Matt, you can go ahead and take that one.
Yeah, and thanks, Marc. I grew up doing geospatial, so it's near and dear to my heart. But a lot of that understanding of not only the outside and the construction, but also the inside, drives sort of how these buildings are maintained and operated for government, right? Thinking about air quality in schools, like Marc was saying, a lot of these IoT sensors can do some amazing things, monitoring the air quality within schools that affect the city's children. From a government perspective, also space management, trying to understand if the district's currently leasing buildings for their agencies to be in, really understanding the indoors and the space management to say we can consolidate agencies into a single district government-owned building, and we no longer need to spend the money on a leased facility to house our agencies. Even things like IT service management. You've got a building with X number of square feet, and you know there's number of assets that in there, like just for example, printers, right? We have a whole system for asset management and service desk tracking. So how many technicians do we have in today, and how do we need to efficiently route them around the city to serve, you know, tons of offices and agencies to support their printers or their computers or whatever. So understanding exactly both inside and outside where things are located, and that that geospatial aspect is really important for things that the government wants to see, as far as how are we doing performance-wise, metrics, KPIs, and then how can we translate those things into really actual savings for the government, I think is really important. And so those are some of the things that we get asked for from the city administrator perspective, to show these types of savings and show how these metrics are kind of being driven around the city, and what agencies are able to take advantage of the space planning and the resource management, the resource allocation, and like how, you know, what about the maintenance of our buildings? Are we efficiently maintaining them? Do we understand how that's working? Do we understand that a building that's recently built is actually performing to something like a LEED certification over time, right? So trying to understand how those things are being done through the modeling and the location-based intelligence, both structurally and internally, I think is really key to understanding from a government ops perspective, how are we going to really save money and help the city to grow and be sustainable ultimately.
Thank you. Brian, you're not currently using digital twin technology at the city of San Antonio, but when we talked on our prep call, you talked about kind of looking into it, trying to understand the ROI, but when you're looking into implementing a new technology like that, what are some of the challenges for the city in investing in something like that?
Money, money, money. Money's a big one. Investing in something like this, while it's still kind of in the early stages of the hype cycle, is always tough for city government to do, especially like in nowadays culture. You know, after the last administration and kind of the focus on smaller government and how government doesn't do jack for anybody. We're trying to identify, like, how do we get taxpayer approval to do these innovative things, to do more in this space, while also maintaining that kind of being risk averse. With this technology, it's important for us, and the way I've been pitching it, and we'll ramp that up over the end of this year, is really about how do we utilize this for storytelling. When we talk about, we were talking about redlining earlier. We can talk about that all day, but when you show it in a graphic illustration on how it impacts economies, how it impacts health, how it impacts health, transportation, workforce, all that, and you show it on that, and Marc, do you have that video online or something, man? I got to hire you to come through and pitch to my city manager. Those things really, they tell a story, and it hits you, and you start to understand it, and that's for any kind of audience. And then, of course, just the planning overall. I mean, it's an obvious thing, whether it's emergency management or traffic planning. We were having a conversation last week with our Center City Development Office and our Public Works and yada, yada. And we were talking about the traffic impact on businesses. You know, we're in the middle of a bond package and executing on that. And as we're tearing up streets, we're also impacting businesses. Projecting how that's going to impact them ahead of time is very helpful. So I think the limitations on this is really the funding, identifying how do we finance this. You know, I think the federal level should be investing in something like this and helping cities out with it at a certain point. I think that would help tremendously. Yeah.
Do you have anything to add, Matt?
Sure, and maybe I'll take it one step since we know the money's always going to be an issue. Sort of talking about it from a planning perspective of carrying out this type of project, and understanding the ecosystem of really, and a deep understanding of what's involved at a technology level, right? There's so much involved really from start to finish, which is really just looking at, you're going to be consuming a lot of data, you're going to be intaking a lot of data. How do we plan to store this data? How do we ensure that we're getting streaming IoT data in constantly so we don't have gaps in the data, right? And how do we make that easily accessible for people to get to the raw data? And then we talk about, how do we move the data around? How are we transforming it? Do we have API capabilities in place? Do we have middleware functionalities in place to move and shape and transform the data as it needs to be seen? Do we have data analytic and data science capabilities, right? A lot of what this, and what Marc was showing before, a lot of this stuff is related to predictive analytics to some degree, right? We have to be able to predict, we have to be able to model, we have to be able to implement things like machine learning, because you're going to be dealing with hundreds of millions of data points that really tell the story that we've been talking about up here a little bit. So I think that's really important. And then also being able to visualize it. You're going to be ending up getting a lot of dashboards. You're going to end up getting a lot of maps and 3D capabilities, being able to effectively show that through tools like GIS and other business intelligence. And then probably one of the most important things, but sometimes overlooked, is talking about the data trustworthiness of the model. So really, are you guys, being able to get data that's encrypted? Is it secure? Is there data privacy associated with it? Is it readily available and accessible? Like the trustworthiness of everything that you've been working to put together. So it's kind of a really large ecosystem of what has to go on to sort of make these things successful. And it's really important to kind of do an analysis of where you are with those kind of the tool stack that you need to sort of support this effort, because it's only as good as the tools that you have. You can get all the data in the world, but what you do with it and how you do it is also just as important as being able to execute that kind of project.
Yeah, thanks. That leads me to my next question. I think Anil.
If I could perhaps add a little bit, I think we're already using digital twins. It's just a new fancy term. We have started using it because it's about what you said, data and evidence in decision making, and then storytelling to the stakeholders, whether it makes sense or not. If you look at it, means we already build assets, operate assets, maybe at an asset scale or at a city scale, using a lot of digital tools. It's a new paradigm, which essentially tells you to collate all this data together, which is a very hard thing to do. Means you can get IoT data from construction machinery today. You can get IoT data from a bulb or a faucet in any building today in your city. So it's really the power of digital twins is this idea of focusing on data and evidence for all our decision making at an asset scale or a project scale or at a city scale. And we've been doing that. It's just a matter of now deploying technology more strategically in doing what we want to really do in terms of not only money, but also perhaps other aspects, including sustainability, governance, and some of the social issues, as you were pointing out. So I think perhaps the term digital twins carries the discussion in a different direction. Rather, it should focus on data, information, and evidence.
Marc, do you have anything to add about the role of edge data in digital twins?
Oh, gosh. Yeah, I would say that if your digital twin journey is taking you to a place where collecting information in real time is part of the solution you need to develop, then yeah, certainly edge computing and the capabilities of bringing information in massive amounts, like we talked about, it opens up the door to conversations about machine learning and big data. But it isn't necessarily a requirement. IoT sensors are not necessarily a requirement. What I showed there were a number of examples of projects that were on the spectrum of a digital twin journey. A digital twin could be the 3D model that you received when a building or a highway interchange got built out that you're able to visualize, click on the individual parts, and get some basic properties about them. Or it could be one step further where those properties actually take you to a table or a view or a heat map or a chart showing historical data about that particular object. It could be information showing you edge computing and edge technologies and IoT sensors showing you in real time what that particular device, whether it's a refrigerator like we were talking about earlier, or the amount of traffic flowing through a corridor, or it could even be so far as that environment being automated and through pattern recognition and AI, gates opening and closing, windows opening and closing, valves opening and closing autonomously. So I see digital twins as this enablement towards perhaps a particular end goal, but the journey along there of enriching your digital information to represent your physical structures is in itself success.
And Marc touched on this a bit in his presentation, how locational data can help bridge different departments in an organization. So, question for Brian, I'll start with you. How can locational data kind of, when it's used to bridge different city departments, how can that help in city planning?
Well, one, it changes our thought process on how we do city planning. I mentioned yesterday about like hiring the right staff. That's another barrier for this. I'm sorry, I'm very candid when it comes to shaming my own organization when I need to. But hiring the right folks in those public works departments is key to this. And I think introducing this to those teams will do two things. One, they may tell you, no, we like what we're doing already, go away. Or two, they may adapt to it and figure out how to do their work better. I think that data sharing across an organization is very tough. Not to mention, in this case, you're not just sharing within the city organization, you're sharing with county, you're sharing with your power systems, your water systems, your transit. How many of you have had to pull together collaborations between quasi-governmental partnerships? How difficult was it? How slow does it take? That's kind of the key things there, and I think this pushes that forward. But it's got to have executive buy-in, and in order to get that, the risk level has to be mitigated a little bit as we're buying into it. I don't say all this to be kind of like a curmudgeon or anything about it. I'm excited to start implementing and pushing this at the city of San Antonio and also Bexar County. But it's just we have to be very honest about these conversations as we move forward.
Matt?
Yeah, I mean, I definitely agree with that. And I think from some perspective, the data that might start out, like Marc showed earlier, like putting together a building, there's a lot of different things that have to be looked at there, whether it's the environment or traffic, you know, the resources that are coming in and out. I think it's really interesting that, you know, even to just build a building, especially here in DC, sometimes you have to think of simple things like line of sight, right? We have a lot of landmarks, and you are, to some degree, maybe affecting the aesthetics of the city, right? By blocking a building per se, potentially that might, you know, obstruct the view. There's things like sun angle that come into play. Could that affect traffic safety to some degree? Are you affecting other buildings in line of sight? You know, what impact will the environment have by you putting this building here, for example? So all these things we can sort of examine through digital twins, right? And sort of understanding as we're putting these buildings in place, whether they're new or existing, right? It doesn't necessarily have to be defined to new buildings. They can be plenty of existing buildings. What kind of impact is it having on other government resources? And then how are those agencies beginning to take in that data, consume it, and kind of work with it as in their kind of specialized area? So it's not always just necessarily the city Department of Planning. There's plenty of other agencies, groups like fire and rescue, right? How do they have to figure out how to get to these buildings, so forth and so on, ingress, egress points, things like that. So there's a lot going on, especially at the city level, that, you know, it's not just one group that's sort of involved. There could be 10, 15 agencies that have some role in how the government responds to something at a specific facility or, you know, a facility being used. So it's a pretty complex array of things that need to happen just for something maybe that seems pretty simple and that happens all the time around cities constructing buildings and things like that. But really understanding how the data itself can be used across different platforms and different agencies, I think is super important.
It's just so overwhelming to hear you guys talk about all the different parties involved and who all needs to be considered and interacted with. So Anil, you are involved in the Digital Twin Consortium. Can you talk a little bit about the work that you're doing there, specifically around creating standards for digital twins and why that's so important?
Sure. So before that, I just perhaps want to give a small example of edge computing. We're based out of the UK originally, the RICS headquartered in London. There's currently a consultation period going on for a new standard for cities that's going to be released. It's called CAP. It's essentially connected and automated plant. To a construction guy, plant means all your tools, equipment, machinery on a construction site. So the edge data that's going to be produced by these equipment, some of them are slowly becoming more and more automated or robotic, can be now standardized. So the data that you will receive, perhaps, I don't know, in a typical city, how many construction, small, medium, large construction sites are there, and how much equipment is running that's producing perhaps impacts on air quality, dust control, and so on. So this standard will tell the manufacturers that if you're going to use this type of plant, which is called a connected and automated plant, on a construction site, this is the protocol to use for promoting data or providing data that then can be consumed by a city in a digital twin kind of an environment. So that's sort of the example of how edge computing plays a role in gathering all that data. But a city may decide not to implement that protocol or not to have that aspect built into their digital twin. When it comes to the Digital Twin Consortium, Marc is a member also. It's a sector agnostic, not-for-profit entity, basically there to evangelize, promote the idea of digital twins across sectors. Marc and I, we both sit on the architecture, engineering, construction side of things. So there's a construction/infrastructure working group, but there's agriculture, there is food, there is transportation, energy, and other sectors represented also. So as part of that group, we basically are trying to promote standards, but also bring use cases and user stories so that decision-making becomes easier, especially when we are during this hype cycle. Everyone and their brother talking about digital twins today. So essentially, a couple of examples from DTC. We have created, some of my colleagues at the working group have developed a maturity model. Depending on how mature your organization is, what scale of digital twin can you adopt or should adopt and begin your transformation journey. In fact, Digital Twin Consortium truly came up with a definition, a technical definition of a digital twin, and it's all freely available on the website. But the most important piece I feel that DTC has provided to the community is the interoperability standard. Because I don't think when we say digital twin for a city, we mean one thing or one tool or one dashboard. It's going to be a connection of systems that play with each other, a bridge digital twin talking to perhaps a bus station digital twin. So you got to conglomerate all these digital twins together. If they don't talk to each other and there is no interoperability standard, we would not be able to connect these various digital twins and produce a city-scale digital twin. So there are two standards, interoperability standards, one out of the UK, the Digital Built Britain, which is essentially a national digital twin that the UK is building. They have an interoperability standard, but DTC also has this interoperability standards so that when you're building and scaling up a digital twin for your city, you know how the various systems of systems can connect and talk to each other, and then perhaps you can pull data from any one of these systems. There are many other things happening that we are doing. Marc is also involved deeply in that activity. He's also working on a group with NIBS and DTC trying to promote more and more digital twin thinking within the built environment space.
Great, thank you. So we've talked about a few different use cases for digital twins. Marc, when it comes to decarbonization and sustainability, what role do digital twins play in the clean energy transition?
Yeah, I forget the exact quote, but what you don't measure, you can't improve, essentially. And digital twins give us a way of collecting information, visualizing it, understanding it, and then making decisions that are informed and fully thought through and understood by a larger group of stakeholders than might typically understand the problem when we're using Excel and databases and proprietary systems. But when we can take information that has been collected in real time and is hopefully trusted and is visualized in context to other types of information. Air quality at a particular point in time is critical to know about, but what are the weather patterns? What's the prevailing winds? What is predicted to occur is perhaps just as important as that particular point in time data that you're viewing. So I think it's a critical element. At a city scale, the purpose of a digital twin should certainly be evolving or revolving around sustainability and resilience, which somewhat go hand in hand. As you get more to a micro level and the actual resilience and sustainability of individual assets, pieces of machinery, then you're talking perhaps more about a dollars and cents conversation of sustainability. But from a socio-economic point of view, digital twins at a city scale allow, like I said, a larger group of stakeholders, constituents to elected officials to be on the same page and to be sharing stories and understand the situation with a common vision, a common view.
Anil, do you have
Sure.
thoughts
So
on that?
I think just to put context, about 41% of the global emissions come from the built environment sector. So there's no path towards decarbonization without the built environment sector playing a major role. out of that, about 40%, 11% comes out of embodied carbon, which wasn't really the focus a few years ago. We all were more focused on operational carbon, which is really when to keep the lights running, air conditioning going, and so on. That's the carbon emissions. But slowly we are realizing that the operational carbon can also be reduced as we decarbonize the grid. And start making more efficient buildings. So the shifting towards embodied carbon is happening, and you're seeing several states now having regulations, starting with simple things like usage of low carbon concrete. Now, really a digital twin at a building level can be very helpful in running what Marc said earlier, and both Brian and Matt also mentioned what-if scenarios. So what if I study the life cycle of this asset and then make a decision, maybe slightly more expensive, but it's going to help me reduce carbon emissions over the whole life of that asset, rather than making first cost decisions. So again, running those what-if decisions, it's easier said than done. I'm sure Brian is thinking, how would you want me to spend more money up front and think about savings down the road in terms of emissions? But that's where we are at, and I think digital twins will play a significant role in running those simulations, helping make decisions, what we call in our business value engineering decisions, whether to replace a window during the design and construction stage with a more efficient, slightly expensive window, so that the overall emissions over the life of that asset can be reduced. And perhaps also it's low on what we call upfront embodied carbon. So those decisions become much easier when we use a digital twin environment.
All right, I've got one more question, and then we should have some time for audience questions if anyone has them, so get ready. But my last question is for all of you. Matt, I'll put you on the spot first since you're next to me. When you think of city of the future, what does that mean to you?
It's a pretty loaded question, but I think it's really about how we can improve the way we do business as a city, the way we do sustainability. Are we responsible for our environment, but also are we really improving the lives of our residents and how the businesses are functioning and how government works? So I think there's a lot to do. This is just one kind of effort that we can do a lot of I would say a lot of sharing across agencies. That's typically been sort of a siloed kind of thing. And how do we open up government and operations and just being able to better improve the way we live and work through technology, I think is going to be really key. And then I think as other cities and governments and states and federal government, things like that, are going through these kinds of efforts, there's going to be a lot of lessons learned that I think we're all going to be able to share. We're all going to be in different places through these kinds of implementations to kind of get to a future city state. And I think we're going to have a lot of really good lessons learned from one another and be able to share success stories and the challenges that we'll need to overcome to really make it successful, throughout the country.
I like it. Brian?
I think, so two things. One, when cities can innovate at the level of speed and impact as private sector. Our most innovative private sector companies, I want city government to reflect that as well. I know that's far-fetched, I know. And then two is that citizens are educated and empowered to participate, to be able to help with the decision-making process throughout government. Rather than being at a distance. We push out surveys constantly, and then residents come back to us and they're like, we got survey fatigue. I'm like, it has to be a conversation. Like, that becomes the norm. That's what I'm excited about. I think that's what we're trying to push for across the nation, honestly, right now.
Awesome. Anil?
Erin, this is a trick. I'm an engineer, so for me, any question, the answer of which doesn't involve division and multiplication is difficult to answer. But I'll give it a try. And I'm going to try and say from as if I'm living in a city with no decision-making power. I'd really like to see a city of the future help me, my human activity flourish. right? So use technology, use partnerships, use stakeholders to deliver that. And that sort of hit hard to me recently. I went to New Delhi, where I was raised, to meet my mother after about 4 years. As we landed, the air quality index read 450. I mean, 450. So the question is, can the city do something to give me a better breathing air so that I can flourish in Delhi if I wanted to? But the response is, we got to wait out the winter period, the winter months, because the surrounding states are burning stubble. There is a lot of other low pressure. There's Himalayas on this side, and the air doesn't move. But isn't there something else we can do? When I moved around, there was so much construction dust. Are we managing that construction dust? So I think with technology and partnerships, we could, and better decision making using data and evidence, we could probably help human activity flourish.
Great. And Marc?
Yeah, I think about the city of Singapore, city, state, country of Singapore, who have in many cases been ahead of the curve in adopting technology, and often, hopefully, to the improvement of the individuals who live in the city. But what they're working towards, keeping the digital twin topic alive here, is a digital twin that would be, let's call it private, and one that's more public. One that's for the consumers so that they can flourish on a day-to-day basis, so they can understand how they're flowing through the city, how their drive to work, how their time in the park is going to be maximized and most enjoyable. That's a much different digital twin than the engineers who are trying to build the next skyscraper, or who are trying to control the water quality, or whatever other civic duty they have as a provider of services to the city, state, country. So the idea of multiple digital twins existing that serve specific purposes, that are built for those purposes, but have an interoperability between them, like we touched on. So I think that digital twins certainly can solve the problems that the city of the future we all want to have. But I don't think it's a single digital twin, and I think they must be purpose-built for the problems that that individual city, state, country is trying to address.
Great, thank you. Got a question from Jason.
Comment and a question. Brian, the sock game is awesome.
Thank you.
Oh, nice. Yeah, nice.
They say let's fiesta.
Always promoting. But question is on the probably there on the use of synthetic data and where that can take digital twins. I did want to get some feedback there. I'm sure you guys are starting to look at that.
Yeah, I've got a former colleague and friend who left ESRI and has joined a synthetic data company. And synthetic data, if you don't know, is this idea of machine-generated data that replicates data that might be collected in the real world, but you don't have enough of that real-world data to apply machine learning or AI against. I think there's a trustworthy issue there. I think that a good example, not necessarily of synthetic data, a little bit of a tangent here, is ChatGPT. OpenAI right now, that's in all the rage, the idea that you could go to a computer and type in a prompt and get some response back. I did that the other day and got false quotes on a project that I asked the AI to tell me about a particular firm and the work that they did. False quotes on a project that this company didn't really even have much engineering work on. The AI responded back that Bob in particular said that GIS and BIM saved the day for them for the construction management. So synthetic data, I think, is critical in some of our problem solving, but the ability to trust it and where it came from and how it's generated, I think, is going to be a little bit in question until we get over a little bit of the hype that AI is in front of us.
That's super interesting. We are just about out of time, so please join me in thanking our panelists today. Thank you all so much. That was a really great conversation.